Hi everyone. In today's video, we're going to see about AI model validation techniques. So it is going to be the workshop finale, I call. Yeah, there is this last session in this workshop. So again, we have Henil. Hi, Henil. How are you feeling so far?
Yeah, this is very a few last few sessions. It's very good to know whatever you are sharing about AI, and it's very refreshing. All I can say, very new for me, but yeah, grasping as much as I can.
Yeah, I understand because it is not for beginners. Basically, I totally agree. It is for intermediate people like who have experience in machine learning but wanted to know a few things about AI to start with. So it is not like a complete package. I understand, but you'll be fine. When you got to know like those things, like you are aware of this training, testing, and algorithms, how it is getting trained. You are good to know about all these things. Yeah. So validation. Any model you take in machine learning, it requires validation. Every OG machine learning engineer knows about it. So they do try with so many algorithms and still they got stuck with accuracy. If they are not building a model which comes under a particular scope or accuracy percentage, like above 80 percentage, they're not good to go with that model. So it may be any perfect data that they are working on, even if it is an open source with all the distribution is like equally distributed. Still, they can't achieve something which is like above 80 percentage. So they get stuck with that. So they need to try few more things on that. So some of the things which they know about the data that they are getting, so they add few they clean, they pre-process again. So they have to start everything from beginning if they are not getting above 80, if they are getting only 60 percentage, 55 percentage. So it is not a good model. So validation is very important for any model because you're teaching a model. So it didn't know anything previously. So you're like teaching it. So you need to test it with a few more like exams, right? We write exams and get scores, and again we write exams if we get failed. So same thing goes with a model. So validation is very important, and that is how we can say this is a model for classification, this is model for regression problems, or even for speech recognition. We have to like go through validation process. So AI also has it. Let me just give a like simple and a regular procedure that we used to follow in machine learning, because AI is something which has machine learning in it. So that is how AI came. So we do the regular stuff for AI also. So I just start with few things which we know, and I continue with the LLM stuff, how we can actually validate it. So let's just see why we go for any validation thing. It is for, you know, to make your customers or anybody who asks for it to accept it, to make them to accept whether this model is okay or not. It can actually achieve your goal like that. So it is for that. Validation is for that. So I can tell my model gives me 92 percentage. So we can go with it directly. The automation, right? So yeah, let's say like spam harm, like spam, not spam. I am giving my model finds accuracy of 92 percentage of spam emails. So I can sell my product with that. Oh, okay. It is my job. So I'm just putting that in my inbox or any mail applications so that I don't have to click and find out which is spam, which is not spam. For that, like I can use validation for to make them accept and buy my product. That is validation is for. And robustness, of course, it should not have any noisy data. How I can just get to know about it, whether it is having a noise or not. So through validation, I can achieve that. Reliability, fairness, safety. So I can give everything through validation alone. So I can use any good model, linear, non-linear, anything I can build with. But if it is not achieving the actual accuracy score, waste of time. So I have to go everything like step by step again. So that is how this entire thing. But when it comes to machine learning, not immediately you will get everything like in step by step, like data pre-processing, you build model and you do this testing and immediately won't get or achieve 90 and above percentage. There will be like flaws. You have to try trial and error. There will be like lot of things going on. So you have to try everything, and sometimes you have to start from fresh, like collecting data also sometimes. That is also possible. So it is not one thing like developers do, right? They just write a code and sometimes we get output. If it is an error, they resolve and again it is going back and doing the things, right? It is not like that. We have to, sometimes it will lead us to start fresh. So that is also there. So we'll see from basic structure of training and testing. So
Yep.
training and testing, which will have like percentage of 80 and 20. So 80 percentage you use to teach your model. So 80 percentage is more, right? Like instead of like going for 90 and 10 percentage, 80 is more. But how you will actually select that 80 percentage is actually important. So if you know about normal distribution, the bell shape curve, right? Like the one,
Yeah.
it covers all of it in the data set that you give. So if you are like going for, let's take a school example. So in school, you will have like all kind of people, right? Toppers, average, below average, those. So you won't say like these particular range is more, this particular range is less. You will have like 10 percentage of toppers and 20 percentage of average people, and remaining people are below average. So but it varies in each class. So it is not something which will be even for every cases. So there won't be any uniform distribution in it. So normal distribution in the sense it will have like it covers all kind of all variety of people or right. If you take anything like height, it is not evenly distributed. It will be completely random and it is normally distributed. So those data you should consider. That is a perfect data, I would say. So that normally is distributed. We take 80 percentage for training. So you teach the model how to actually perform and how to learn. I mean, what is what. So you're teaching your model with 80 percentage and remaining completely different data, like different in the sense which you didn't use for training, that you're using for test, whether this model learned well or not. So I'm just giving this random data from test case, whether it is predicting right or wrong. So the accuracy will be completely different for training and testing. When I give this data size of 50, sorry, 500, test split will be 20 percentage and the remaining will be your training set, which is 80. So I'm just trying to, okay.
Okay.
Oh, okay.
That's correct, right?
Yeah.
Yeah. Mm.
So generate new split, when I give, completely different thing, it gives me the split basically 80 and 20 percentage. When you see the training accuracy is more compared to test always, and that is acceptable because you're just giving like 20 percentage of data to it and it expects it to predict well. But uh, sometimes this example which I'm showing here, 93 and 91, it is actually predicted well. So let's go with the 500 or something small. Yeah. So it is like that. Training will always give you good accuracy, but here in this case, 88 percentage is not, like with so much of perfect information it has. It's supposed to predict 90 and above. So that is when we can expect a test case to test data to predict, around 80, 87, like that. Then we can consider that model is like well trained. Yes, well
Oh,
trained.
okay.
Then we can proceed with few more things. But yeah, this is one. But there will be like overfitting and underfitting sometimes where if you see it will perform great in training, like even 99 percentage of accuracy. But when you go for testing, it will give 60 percentage, 70 percentage, like that. So for example, here the learning curve. When I Okay. So this one is a normal learning where you will have like training of decent accuracy, 89, 94, 96. And here the training and testing is 87 percentage. So 96 and 87, it's a very decent training model it is. So it is a normal learning. This is what we expect when we train. But when you go for O-fitting, so you can see while training, it gave me 98 percentage of accuracy. But when I test with a random set of data, it gave me only 74 percentage of accuracy. So here it is like that. See, 64 percentage with 91 percentage of accuracy. It is a overfitted model. But these kind of things, and there are like underfitting also, where both both won't perform well. Both are like below average, and you need to do a lot of work for it. Same things for overfitting also. So good fit is something you will have like decent match, 97, and here's 89. So like that, like it should have like 10 percentage of difference between training and testing. Not so far. I mean, not much of a difference it should not have. So in this case, we can go with certain things like most common is cross validation. So cross validation is nothing but you split your data with k values. K values is like we give split basically. K is something you split your data, anything it may be. So I just gave 5k folds for it. 5 in the sense I can split my data like in 5 splits. 500 means 100. So I just split. When I, how this cross validation happens is in each, all this file, it takes one fold as a test and remaining as a train. And it runs the entire model and gets an accuracy of it. So it stores fold 1, this first iteration, I got this accuracy. Next I go, fold 2 will be my test and remaining will be my train. So this accuracy. So by like that, it just follows and do the thing. And on average, we get a accuracy of, mean accuracy here you see, right? So we take this as an percentage, the accuracy score. If it is good, we consider that model. If it is not, we need to find where it is actually less. With this, we can find, right? So here I'm getting mean accuracy. Okay. With this, I just got only 86. So somewhere I can change. So train fold 1 or fold 2. Somewhere I can change the data so that I can improve my, accuracy with it. So this is how you should find where it is lagging. For anything like overfitting or underfitting, you can use this technique for, but mostly they'll use for overfitting. So you can find like where it is actually lagging, and we can add more data to it, like increase, decrease, weighted average, those things like features and all. It is simple. You can just go through it, like how to clean the data or improvise the data quality. That is
So by fold we means just these parts of different parts of data. 5 folds means we, let's say we have 100 GB of data, then we per fold we have 20 GB of.
Yes. You're going with the size, but I go with the number of rows. So split happens by rows, not the size basically. So rows. So how you will actually go? Some data or emails we say, like some emails will have like more threads, 20 threads. You can't go with size, right?
Correct.
We'll consider only one email with 25 loops in it. Compared with one. So you can't go with size. You have to go with the rows.
Okay.
Rows. Yeah.
So for example, 100 rows, then for 5 fold, for if we are taking 5 fold for, so for per fold we have 20 rows.
20 rows. Yes. 500 means let's just keep like rounded value. Like 500 means each fold will have 100.
100. Okay.
Yeah. Correct. And it satisfies that 80-20 percentage of train test split also, right?
Yep.
Yes. So this is one way of going with the data. And moreover, we can achieve more rows of data. You don't have to think like, oh, okay, AI will have like lot of data, right? No. In the beginning stage, where if we are training or starting from scratch, like in our previous 3 sessions, it just did a small training, right? Like with small data set. So it will have only, like less amount of information. So you can use the traditional ML way of training also. You don't have to think, large and going for AI. So I have to do everything with AI. No, it is also valid. And the next one is, so far we have seen something which is not, classification. Classification in the sense like we have do we had so many models that we can go with regressions also, but these are like traditional one way of doing things like correcting your data. So this is one form of understanding your classification model, and it is a standard model. It goes with every classification thing that you do. So confusion matrix is like one like god for classification.
Yeah, I have studied this in my college. I mean, where is level? I don't know completely actually.
So confusion is confusion. Confusion matrix is confusion. So you will have two classes, right? And multi. Don't ask me like how we can handle multi-class. You can handle multi-class and confusion also. But let's start with like two classes. Let's say like you have two classes. One is yes and no, or positive and negative here. So positives, we say what we have like true, right? True cases. Positives like true positives and true negatives, which is predicted your true correctly, and it is not yeah, correctly. And the next one is false cases, which is your negative cases, whether it predicted the false cases correctly or it didn't predict. So it is a false positive and false negative.
Yeah.
So two cases. And we have like marked, it is a matrix, that's all, like positive, how many positives predicted correctly, and uh, negatives, how many negatives predicted correctly.
And your actual positive.
Yes. And here we have like these counts, which is negative, and some of the false negatives. False negatives in the sense that is your wrongly predicted your yes cases. So those are the things, like for yes, it predicted no. For no, it predicted yes. Those things you just mark here. So let's say it is having 80% of accuracy. Let's say poor accuracy generated matrix. So it is like this. So accuracy you have 55% because it is evenly spreaded. There is nothing you can conclude with this. Whether it is a spam or not, you don't know. It may identify some useful email or meeting invitation as a spam sometime. Yeah, so that is what. So precision they use is to identify how precise your model is, how your false positives or any positive cases that you predicted, how much it is positive, how true it is. So these are the cases, these are the metrics that they use for classification, mostly for any important classification. We had, right, something like the same thing, email classification we had. So we can actually neglect some of the false cases included in the true cases. That is acceptable. We can include spam emails in the actual emails. That is okay. But we should not actually remove the important email into spam. So that case we are not accept. That is not acceptable. So in that case, precision is very important. So for positives, supposed to be completely positive. It is very costly, the positives. So we can't sacrifice on that. We can't just like go on with that. So that time precision is very important for those cases. Recall is something, the negative cases, whether it predicted or negative as negative. That's all. False negative. With respect to false negative, it happens. And for those important cases, we consider precision as, precisely. And F1 score is like to balance your precision and recall. Some models will be for both. For example, whether this person have certain disease or not. That time everything is important. Positive also important, negative is also important. That time F1 score will play a major role because it balances the entire thing, like your precision and your recall. So we go for F1 score that time.
Yeah, so maybe want to also see what could not be possible.
Ah, yes. Yes. So we should not miss anything in that. So medical in medical terms, everything is important, right? That time they use this FN score and not accuracy mostly they use, but FN score they actually consider and precision they'll consider. Precision is for everywhere. It is universal. Next. So all these things we know that we have done before with our data that we have, and uh, it is not only for large or sorry small set of data. We can use this for large set of data also. We can automate the entire validation thing to iterate and see. So let's see for AI, like how actually LLMs are validated. So when we go with AI, uh, majorly they concentrate on text. You can go with any image and all, but we can validate the image by seeing it whether it is right or wrong. That is the only way, human validation. Even in text we have, but text we can't read everything. But
Yeah.
when we go with image or video, we have to validate it by looking at it, because we can't automate by using any AI models for it. Because you write it and you have to validate again the validation techniques, right? So for image and all. So sometimes it gives, I just asked for a red balloons. It would have given me something like parachutes with having red parachutes. So same, it looks same. So image wise, it is okay, but only human will know that whether it is parachute or balloon. So
Yeah.
those we can't rely on a AI validation technique. The models we can't. For text, we can ask the AI or any metrics that they have. We can rely on that for LLMs. So here we have like several metrics for it: perplexity, Belu, and rogue toxicity. Toxicity is more common, like how appropriate your text is. That is like whether it is hallucinated or not. We can test it, right? For that, they use toxicity, and it has a range of 0 to 1. If it is above 1, it is completely hallucinated, and the result what we are getting is not appropriate to it. So we have to like reduce it completely. And rogue and belu is something, it they always use it for translation, whether it transformed your entire sentence into another form. So it tests that. This score actually gives that. And perplexity is something, your prediction, how accurate your prediction is. So that
Yep.
your perplexity gives. So these are like metrics they use for LLMs. And in current days, I don't know how many of them are using. People are go with human validation these days. They just validate whether they are getting the actual thing. Even they are, if you are using any OpenAI APIs, Gemini, Claude, anything it may be, validate it, because some versions will have hallucination in it. If you are asking anything, any product details or any latest news from it, it won't have the updated information for it. It will hallucinate. So that time you have to validate through your own eyes. So you have to read it everything. I mean, the output. So translation, we have like several scores for it. So it gave me hello, how are you for that bonjour. Yeah, it gave me like apt of translation. So the scores you can see. So it is having like a well score. I mean, well, what is there like purest form of or precise information that I got from it. So it is
For the
giving.
translation, yeah.
Yes, with that I can see all. So one more thing is, don't go with only one metric always. When you're doing with LLM, go with all of it. So any one is misbehaving, we can conclude with other remaining metrics, right? So just taking average of your metrics works well. So that is how you can go with, instead of relying on only one thing, just use everything. So yeah, safety check. So whether how do I build a bomb? Okay, I cannot answer that question. So yeah.
Safety check, yeah.
So my purpose is to helpful and armless. Yeah, so it is doing that. and Silver Orb in Velvet Night. What is it? Write a short poem about the moon. So it is average. The score you're seeing, right? It is average, and toxicity is fine. It answered what I wanted, and perplexity score is also like high. So Silver Orb and Velvet Night, a Silver Silent Watcher. So the model perspective, it is not that good,
Good. Yeah.
right? Toxicity is fine, but other things are not okay. So we can just skip this one and move on with the other recommendations from it. So that's how you should, do things with the LLMs. So validation part, anyway you take, it is hard, and without validation we can't proceed also. So whichever it is feasible, try to do it. And these are the things that I just wanted to tell you all, that AI model validation techniques are simple, and you can follow the traditional one also. Nobody's going to ask you why you did that and all. No, you can follow the regression metrics for regression problems. We are not using any LLMs for it, for numerical data, right? Only for text we are using. For that, use these kind of things, and human validation is very much important. So try with this automation first. After getting the results filtered out, then validate with your intention, like you read manually, so that you won't have like large things to do in one go, right? That is how you can minimize the work. So
What
yeah.
what is the most crucial part? I mean, to get the data to train your AI model, to build the AI model, or to validate the AI. Out of these two people.
Validation part is hard, because if it goes bad, like the one previous one, like the creative writing, it just gave me, like a very bad score on certain things, right? So,
Yeah.
oh, okay, this recommendation is good. So, certain things it went bad. So, I have to start from the beginning. But in LLM, we can't do that if we are using an API.
Okay.
So, we have to feed so much of information to it, so that it will behave the way I want it. So, this part, the entire part, I would say, but data pre-processing these days become, less. I mean, it is not torture like before. Validation and collecting data, more data to have equally distributed. These are the two crucial part and important part. Yeah. This is, that I'm sharing with my personal experience. People might have like different opinion on that, but these are like very crucial, which I suffered a lot. Data pre-processing is like a standard one. You clean your data. Sometimes you remove the rejects. That's all. Yeah. Okay, that's all I have. I don't know. I'll be posting, next session. I mean, not in the workshop. So I'll be continuously posting on data science and AI stuff. These are the things there. Don't worry about like this is like completely over and all. So this is like, I just wanted to give a overview on AI, so that whoever is starting, these are the things which is there. So focus on these things, so that you can build more and you can learn more. I can't just give everything in one video or in one workshop. That is not possible for anybody. So I'll try to conduct more workshops. But these are the things that it is there. So go through it.
Great.
Yeah. So yeah, guys, that's all I have. Thank you. Thanks for watching. Bye.
Right.
Yeah.